Hey, welcome to our math. Today I'm doing a series of videos on graph interpretation. For this graph, we are looking at a bank, any bank, interest rates, and the day that the rates were given. Now, the lines are connecting these, but with the way interest rates work, these are really just separate data points. You connect them to kind of get a trend of what's happening. You know, overall, the rates are decreasing, but halfway through the second day, it's not going to be further down. This 1.475 is actually going to work for all of day 2. This graph should probably be made with like horizontal lines with an open hole and a horizontal line and an open hole and a horizontal line and an open hole. This is called a step graph. Don't worry about the step graph. That's not the point of this video, but I do just want to state that so that if we get something that's somewhere in between, I'm going to use the actual day because rates don't change. You consider it day by day idea. Okay, it says find f of 2. F of 2 is my input. Input is always at the bottom. So I'm asking what is the rate on day 2, and that's 1.475. F of 6, well, my input, because it's in the parentheses, is 6, and the output is 1.3. It says what values of f of x equal 1.3, and the reason I did 1.3 is because that's a repeat value, and it looks like, you know, right here at 3-day, 3.9, but once again, because of the way this graph is meant to be interpreted, even though there's 2 times we cross the 1.3, because of the type of data we have, we're just going to say it's day 6. We don't have part of days. Okay, so it says interpret f of 6 equals 1.3. So at any bank, you need to give details like what you're talking about. At any bank, the interest rate on day 6 was 1.3%. So notice the 6 got a label of day. Notice the 1.3 got a label of percent. Also notice that I didn't just say on day 6 it was 1.3%, because that doesn't give me all of the information. The interpretation should be something you could give somebody without the graph, without anything else, and they should know what you're talking about. So you had to say at any bank because not all banks have the same interest rate, and you had to say the interest rate because you had to know what we were talking about. Okay, so interpret 2, 1.475. These are exactly the same, and one of the nice things about of function notation is the input is first and the output is second, which means function notation and an ordered pair are written in the same order, which is convenient. The other thing is once you have an interpreted sentence, you can use it word for word, changing the data that you're using. So for number 2, I'm going to start off with at any bank, comma, the interest rate on day 2 was 1.475%. Okay, what interval does this graph increase? Well, it increases right here. It increases from 5 is less than or equal to x is less than or equal to 6. Or we could, see, I keep on falling for those equals. 5 is less than x or less than 6 because this point is not increasing, it's held steady. This point is not increasing, it's held steady. It's just between those 2 dates, between 5 and 6. What interval does this graph decrease? Well, it decreases from 1 to 5 and 6 to 7. With our interval notation, it would be 1 to 5 joined with 6 to 7. That's like it. This is called a union, and it's kind of like united we stand. We join those 2 intervals together and we get all of the intervals where this decreases. Is there a max or min? If so, what is it or are they? Well, there's a max right here. The max is at 1.5. The min is right here at 5. Nope, it's right here. These two look very close, but 1.1 is smaller than 1.125. So it's at 7, 1.1. All right, I hope you've enjoyed the video. I hope you've learned something. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.